We're ending with a very exciting panel. I'd like to now introduce back up to the podium Patricia Cooper, who is our newest board member at the Future Space Leaders Foundation. She's already obviously doing a very critical part of our programming with our final conversation here. She is the president and founder of Constellation Advisory. She's moderating our next panel on space sustainability, which I think, by my count, has come up in 3 different conversations today. I think we only had 4, so that's pretty good. So we'll end the day on the topic that has kept coming up. If Patricia and her panelists will join me up here, and we thank you again.
Thank you. Hi, you guys. So Merissa, you here? Ashley, you third. I feel like I'm doing the best in show. Where's Tom? There you are. You're right here. So, good afternoon. I'm Patricia Cooper. As Bradley said, I'm a consultant now, but I've been through government twice. I've worked for 2 space startups, 1 traditional space satellite company, and ran the Satellite Industry Association for 7 years. Most recently, I was at SpaceX for 6 years as VP of Government Affairs for Starlink. So I've had a bunch of different types of jobs, and I've had a lot of different vectors, but I'm a satellite girl. I'm a policy wonk. I'm not a lawyer. That's the first question most people ask. And I grew up with engineers, but I'm not one. So if you ever want to talk about getting into space, either by accident or on purpose, without a technical or engineering background, I've got lots to say. But I'm very excited at today's panel because we get to be what I consider the cherry on top. We're not batting cleanup. We're not standing between you and cocktails. We're the cherry on top. Because space sustainability is not only one of the most overused buzzwords, but it also encompasses almost everything we talked about today. It encompasses safety in space. It encompasses human spaceflight. It encompasses everything that's changing with commercial activity in space, with a richer set of activities in space. And no one really is very good at defining it. So this is going to be a very interesting panel, partly because it's going to help inform some of the questions I heard earlier, which is how do you project what this quickly moving dynamic industry is going to look like 3, 5, 10 years from now when you are coming into your own in this industry and planning your kind of future out. So space sustainability, I think, is one of the ones to keep your eye on, because where space sustainability goes, I think the industry will be highly affected. So we're going to talk about a whole bunch of things we talked about today. Orbital debris, like how do you what is on orbit, how to track it and catalog it, how to avoid it, how to remove it, how to refrain from creating more. We're going to talk about the impacts from an increasingly utilized space ecosystem, like where could or should spacecraft be placed? How long do you get to stay? How do we keep track of them? There's a whole bunch of questions that we also have related to humans in space. How do we keep humans safer as they manage their way through the space environment and create long-lasting presence, whether on the moon or on Mars or at a space station? We also, I think, have hit an inflection point about the way we think about space. You heard the congressman talk about space is big. I increasingly believe that we have moved on from that thinking, that you can just leave stuff up there, it's okay. There aren't that many players, there's not that much happening, the ecosystem is enormous. I feel like we've hit a similar inflection point that we did with the Earth's environmentalism. It's no longer okay to litter, it's not okay to pollute. There is a value that I think we've turned a corner on in space about environmentalism, and it includes things like, what is the effect of more increased launches and satellites? What is the effect on visibility from having more objects in space, and what do we do about it? And how do we share and coexist fairly and effectively in the space ecosystem? So these are big questions, and we are lucky to have an incredible panel of experts who I consider friends, and I admire what they do. So we're lucky because they can unpack this together. So today we will be hearing from Dr. Tom Colvin, who's the Senior Policy Advisor at NASA's Office of Technology, Policy, and Strategy. next to him, Merissa Velez, who is the Chief of Satellite Programs and Policy Division at the FCC's new Space Bureau, which was created about a year and a half ago. And then next to her, we've got Dr. VanderLey, who's a senior advisor to the National Science Foundation's Division for Astronomical Sciences. She'll talk about how the science side of space intersects with these changes. And at the end, we've got Jennifer McClellan, who is the US Program Manager at Astroscale, to talk about cleaning up space. So I asked all the panelists 2 questions. One of them is, what are you thinking about when you think about space sustainability? In this big umbrella of issues, what piece of it do you have? Are you active on? I also asked them to maybe think about what piece worries you, or are you planning to get to? What's kind of the next thing in that job jar of space sustainability for your current role? So Tom, I'll ask you to start, if you don't mind. Thank you for being here, and I'll let you go.
Test, there we go. Okay. Hey everyone, Tom Colvin, as you said, Senior Policy Advisor at NASA, because he really nailed it. I love space and I don't want to work out. So, you mentioned first off, right, like front of mind, what have I been working on lately? What are we working on? I've been doing space sustainability for the last couple of years. And for me personally, one of the things that is front of mind is, lean a little forward so everyone can see. Oh, hey, Bradley. Is how do you measure space sustainability, right? Like, everyone thinks it's important. Everyone has their own definition. There are many official definitions, but they're words, right? How do you take the words into something that we can measure? Because if you can't measure what you're doing, then you don't know if you're doing better, or you don't know how much better you're doing. When we were writing the Space Sustainability Strategy in Earth Orbit, Volume 1, if you're interested, I recommend you all go read that. We released that a few months ago. This is kind of goal 1, objective 1. Everyone's talking about space sustainability, but they're talking past each other. What do we mean? Let's get everyone on the same page, and how do you measure it? And it's important not just to know whether you're doing better or not, but because how you measure a thing influences the way that you think about it. So the way you measure space sustainability affects the perceived severity of the problem, the locations where things are maybe going, worst of all or possibly best. It changes the types of actions that you might consider to address space sustainability and when you think those actions need to be taken. So just kind of concrete example, a metric that gets used a lot is counting the number of pieces of debris in space over very long periods of time, like 100, 200 years. That's good for some things, but it is also a little bit problematic. I won't go through all the reasons, but I'll give you maybe one example. I think we can all agree that better SSA is important, better space situational awareness, being able to predict where pieces of debris are now and in the future, so that way we can maneuver to avoid them. But if our metric is how many pieces of debris are in space in 200 years, well, how does SSA really affect that? It doesn't make a big change in the number of pieces of debris because it's attacking a different part of the risk that we're worried about with respect to space sustainability. So if you measure things by just bean counting debris 200 years from now, things like space situational awareness is not going to rank very highly. But that doesn't seem right, does it? So maybe that's not the best metric. In my work for the last, I brought a timer so that way I wouldn't talk too long, but I forgot to hit start. Okay. So in my work, I've been trying to estimate the risks, estimate space sustainability, measure it by the dollar value of risk that is imposed on spacecraft operators operating in space and interacting with debris, right? So if a piece of debris gets too close to you, holy cow, like you gotta measure, or you gotta do some risk analysis. You gotta put some people on it. If it gets too close to you, you gotta maneuver to get out of the way. And if you couldn't see it, it's gonna wreck you, right? It's gonna hit you, and that's lost hardware, lost operations. So we've been quantifying these costs. And when you take that more dollar-valued approach and measure risk directly, you start to see some things that are a little bit counterintuitive. I won't give all of them, but one is that when it comes to debris cleanup or remediation, the thing that we estimated as being one of the most cost-effective things to do is called just-in-time collision avoidance. So instead of removing debris, and removing debris is important, but as a different way of going about this, you could leave debris in space, and if you see two big things that are about to hit each other, use like a laser or something and nudge one of those pieces of debris away from the collision, right? You've avoided the collision, and what's the problem with debris? It hits stuff, right? So if you can neutralize the risk of debris hitting stuff, you've neutralized the risk of debris. And this could be a very scalable, cost-effective way of improving space sustainability. And then we only need to do the, say, removal of the pieces of debris that, for which like are going to pose re-entry risk to people on the ground, or are just really, really high value risk assets, and we need to limit our liability. Still important reasons to do deorbiting, but it's trying to encourage everyone to think a little bit broader than that. So on the horizon, I've been thinking about measuring space sustainability. On the horizon, I promise you this will be shorter, is how do we think about space sustainability in lunar orbits, in cislunar space on the lunar surface? When we were writing the space sustainability strategy, Volume 1, which came out in May, we just focused on Earth orbit, but we called for one of the next volumes to be on sustainability for cislunar space and the lunar surface. And there are a lot of outstanding issues. I'll give maybe like one technical and one non-technical. Maybe you've heard of the term plume-surface interactions. This is a very hot topic right now. The basic idea is that when you land on the moon or when you take off, that rocket plume is going to dig into the lunar dirt, and it's going to send it at hypervelocities off to the side. That dirt could go up to altitudes where spacecraft are orbiting, possibly hitting them, and it can rain back down on crewed and robotic assets elsewhere on the lunar surface. What do we do about that? Right? How big is the risk? Don't know yet. We need to think about it more. Lots of actions that could be taken. Need to think about it more. But this is a horizon issue that is going to be quite important in the coming years. A totally different tack is there are a lot of ethical issues associated with lunar exploration. I'll give just one, which is that if you're walking through the forest here on Earth and you leave some footprints, that's fine, right? But if you're on the lunar surface and you take a step, that footprint may be there for thousands of years. And so we have to think about how we can balance our ability to explore and utilize the lunar surface while also preserving its aesthetic, cultural, and scientific value for generations to come. So these are just two different issues that are ascending in importance and that I would encourage everyone to pay attention to. So. Thanks.
Fantastic, thank you. Definitely plenty still to work on is, I guess, what you're saying.
Yeah.
Merissa, I'm very excited to have you here because I used to work at the FCC like 20 years ago, and I wouldn't say it was dusty. We felt we were busy. But in the last 10 years, the activity at the FCC has, I don't know what actual increment it is, but hundreds of thousands of satellite applications for hundreds of thousands of satellites are now resting with an agency that used to see maybe 15 or 20 a year. And as a result, that agency has created a space bureau specifically for it, has looked for new talent to try and handle some of the new questions that are brought on by this new activity, which maybe I helped a little bit with in my last job. But I'm really excited to hear what you have to say about those two questions. What worries you now? What are you working on right now in terms of space sustainability? And what puzzle is still ahead?
Yeah, absolutely. And thanks so much for the introduction to the FCC and some of the new work we've been doing, well, continuation of our work we've been doing for quite a while, but now in the new Space Bureau. So I'll talk a little bit about what the FCC's role is, what I do there. I'm a lawyer by training, and so I think in this panel maybe I'll bring a little bit of the regulatory perspective on some space sustainability issues. In particular, the FCC regulates satellite communications, so commercial communications, experimental communications, anything that's non-government. So we don't deal with any U.S. government satellites, but pretty much everything else that's a U.S. satellite is something that the FCC would see as far as authorizing the communications. As part of that, the FCC has, for now over 20 years, reviewed the orbital debris mitigation plans for those satellites. Initially, it was largely GSO satellites with a few NGSO constellations here and there, but as the shift in the types of satellites that are being launched has happened, the types of orbital debris mitigation plans we've been seeing has changed, and we've been working to update our regulations to stay up to speed with that and kind of keep up with the pace of technology to the best of our ability. So this, as Patricia mentioned, the Space Bureau was created about a year and a half ago. We did have work on satellite licensing prior to that, but the Space Bureau, I think, is a recognition of the need to respond to the new space age and to promote a competitive and innovative communications marketplace by leading in policy and licensing matters related to space-based communications. It's interesting that we have a Space Bureau now. The FCC was actually created through the Communications Act of 1934. So things have evolved quite a bit since then. But the FCC has had a role in commercial space communications from kind of the outset of those types of communications. And I think now, and it's a really interesting time to be a regulator for commercial communications, because most of the satellites that are in space are commercial satellites at this point. So it's been a really interesting shift, and I think we, as I said, have been working hard to try to update our regulations and make sure that we're both acting as a regulator, but also facilitating the need for speed and innovation. And so we're trying to work to create an environment where there can be innovation and competition in the marketplace. At the same time, we're listening and learning from our interagency colleagues on many of the space sustainability, orbital debris mitigation related issues, working closely with colleagues from the agencies that are here, other colleagues from FAA, Commerce, other agencies, to make sure that we're all on the same page, and that as we're updating our regulations around orbital debris mitigation, we're taking into account some of the broader issues. Just to give a little bit of a sense of how we actually review these issues at the FCC, we will license the operations of commercial satellites, and at the application stage, so the time when a company's coming in and they're describing their system, they're describing the radio frequency operations they're going to be using, they also provide their orbital debris mitigation plan. So as a disclosure, so they say this is what we're going to do, and they cover a number of different areas. They cover collision risk, they cover potential risk of human casualty for satellites that are re-entering Earth's atmosphere at the end of life. They describe their plan for disposal of the satellite and the reliability of that. So a number of different areas that they cover. And so we review those plans at the outset. We may follow up with questions to the applicant depending on what they've described. We review them under our rules that we have set out in these different areas. And based on that review, we might condition their license or authorization on taking certain actions related to orbital debris mitigation. And it could affect our decision-making as well, just on whether to grant or maybe defer part of their application. So that's sort of how our review comes in and the regulatory process works at the FCC. So I'll maybe turn a little bit to some of the areas that we're thinking about right now and working on. One of them is continuing to update our regulations on orbital debris mitigation. As I said, we've had regulations in place for over 20 years, but have been working on those. And we have just recently even refreshed the record in that proceeding, asking some questions about issues related to large constellations. We're also looking at updating our licensing processes in ways where maybe our rules don't necessarily make sense for the types of missions that we're seeing. So are there parts of our licensing rules that are geared toward more traditional operations that maybe might not be quite right for in-space servicing mission, for example, just because of the way that the application process is structured, and looking at spectrum issues as well. So there's a number of areas where I think we're really engaged right now, and also, again, listening to what's happening in the broader US government and internationally on many of these issues.
Great. Thank you so much, Merissa. So Ashley and I have had maybe an unexpected opportunity to work together on the issue of constellations and their brightness, because I was at SpaceX when we had our inaugural launch, which attracted the attention of quite a lot of astronomers around the world because they were unexpectedly bright. So that has been a fascinating topic to work on because it brought two really well-developed parts of the space community together who never talked, the astronomers and the communication satellite folks. And it has been, I would say, a rich topic to learn about and try and bridge. And Ashley's been at the middle of it and a voice of reason and always focused on trying to advance where we go from here. So Ashley, I'm so glad you're here. Thanks so much.
Great, thank you, Patricia, and you have been fantastic to work with. So that was my first kind of introduction to the satellite community, and I think Patricia is a fantastic ambassador. So it's a real honor to be here. It feels like yesterday I was actually in your seat attending some event where there was folks, and I was a little overwhelmed with the titles and the jobs that the people were doing up in the front. And the one takeaway that I remembered was that each person always pursued their passion when there was kind of, different roads that you could take. So that's one thing I just wanted to start out to encourage, just keep studying and pursue different opportunities, because I never thought I would end up where I am, and it's actually just been an amazing journey, and so I think that's something to keep in mind. When it comes to space sustainability, where are we now and what worries me? So one thing I wanted to just kind of bring to your attention, I don't know how many of you have seen Carl Sagan's Pale Blue Dot, where it looks back and you kind of see the Earth from a distance. And this image is something that kind of really gave us perspective of our place in space and actually how fragile life is. And this is something that I think really helped the environmental movement and people thinking about we have to take care of this planet. Similarly, I'm not sure how many of you have been in a dark area where you can actually see the Milky Way galaxy. If you haven't, I would encourage you to go to a dark skies preserve and actually take a look at that, see asteroids, falling, and just see how amazing that looks like. Well, that's another example where early in the history of humankind, as we were trying to understand our place in space, people first just thought, hey, there's this Milky Way. We also see a combination of what they call planetary nebula, and they thought that our galaxy was the only galaxy, and there was kind of these other things floating around. But through very, very careful astronomical observations, people found globular clusters orbiting around the center of that Milky Way. And they started to see, hey, we're living in a disk. This is a spiral galaxy. And then they started to realize that these island galaxies were actually other entire galaxies that existed. So it was just incredible to learn kind of the scale of the universe and our place in it, that we were not the center and that we were in this very, very rich environment. Now fast forward, I think probably a couple of years before most of you were born, in the late 90s, was the very first time that an extrasolar planet was discovered. And so this is also remarkable. For a long time, we thought that our solar system might be the only one that existed in the universe. And so from the very first extrasolar planet, now we are in an era today where there's thousands and thousands of planets that have been discovered around other stars. And so the key scientific search right now that NASA is leading the way, and we're trying to do follow-up from the ground, is to discover a planet that has the conditions for life like Earth, which is just fascinating. And so I bring up all of these things to say, I appreciated what the gentleman from the Space Force said about, what's great about America is our economy. Yes, we need to make money. We need to have a great economy, but to me, the thing that is the greatest about our nation is the imagination, the creativity, the fact that we're seeking to understand our place and that there's something bigger than ourselves, and that's kind of, I think, what's driving. And of course, we need to make money to take care of our families and to build this great nation, but it's something kind of in the spirit that drives us. And so that's where we come from, the perspective of an astronomer. So I did my PhD in astronomy at the University of Maryland, never thought I would get into public policy. And now I work with the Division of Astronomical Sciences at the National Science Foundation, where we operate for the US the ground-based optical, infrared, and radio telescopes. So we work very complementary with NASA, trying to do anything that requires a much bigger aperture that's hard or very expensive to get up in space. And so where we have seen concerns and what has been worrisome is that, these new generation of satellites, first of all, there's a lot more of them, as was illustrated in the last presentation. But they're also much brighter. And so at first, astronomers were not concerned. And honestly, we raised the issue and we got blown off. And so this, again, is a lesson in humility. We don't know what we don't know, so keep asking questions and be curious. So it turns out the satellites are so bright that the concern is not that there's a streak in your data, because astronomers are really good at removing streaks from their data in the optical. The problem was it was so bright that it actually causes nonlinear effects in the CCD that are very difficult to remove from the image. So it doesn't just impact the streak, but it impacts the entire image if there's not a way to properly correct for that. So we immediately started thinking, okay, how bright would the satellite need to be so that we don't cause these effects and we can actually remove the satellite streak from the data? And so we found working, the Rubin Observatory is going to be fantastic. It's the next large ground-based telescope that the National Science Foundation is building in collaboration with the Department of Energy down in Chile. And it's going to create a movie of the entire sky over a period of 10 years. It'll be doing images every single night, very large field of view, like 8 degrees by 8 degrees. And so those scientists told us about 7th magnitude brightness, which is about what your eye can see, stars about that bright. If it's brighter than that, it's going to cause issues for the Rubin telescope. So that's where we immediately started working with satellite colleagues to say, hey, let's see what can be done. Now, luckily for us, a lot of the satellites in orbit do also transmit in the radio. And there's a very, very structured process for coordination in the radio through the FCC and also the International Telecommunication Union. So this is a specialized agency of the United Nations that has very specific rules for radio transmissions. So we'd already been coordinating because we were concerned. We wanted to make sure that, for example, telescopes in the radio quiet zone and the VLA, which is the 27 antennas out in New Mexico, we wanted to make sure that we could continue to do science with that. So we'd already been coordinating with SpaceX and with other companies in the radio. So when the optical issue came up, we started discussing, hey, what can be done? And what I found remarkable is that, especially in the space industry, a lot of people are captivated. They love space, right? They've read astronomy magazines, all of those things that I told you. You were all nodding your head. I could see that you knew these things. And so, I think we have a population of folks working in the space industry that really does care, right? They want to make sure that we can fix the problem. So we were thrilled to see that there was no regulations requiring it, but SpaceX and many other companies, including Amazon Kuiper, for example, we've also been working with OneWeb, AST Space Mobile, we've been in conversations with. They've all started taking steps to find ways of reducing the brightness of their satellites and then coordinating with us to try to develop that. One thing I wanted to mention is, when it comes to space sustainability, one thing that also connects and is important for us to be able to detect very faint objects and not have a particular area kind of ruined is the area of planetary defense. And so this is an area that we do collaborate with NASA's Planetary Defense Office. And it turns out that kind of incoming asteroids are easiest to see at twilight because the angle of how the sun hits them, but that's also where satellites are the brightest. And so we want to make sure that we can track, the faintest, and we know where all the asteroids are. And then there is a really, really neat kind of project being led by that office, so that if there was ever an asteroid large enough that it would actually hit Earth and could cause lots of damage, there's folks thinking about how you could actually divert that or break it into pieces to be less harmful. So that's, from a sustainability perspective, we're concerned about the debris caused by satellites hitting each other, but also incoming asteroids and what that could actually do to the population on Earth and, of course, the moon as well. In terms of puzzles still ahead, there's quite a few of them. I would highlight, a big question that we've been asking is, simply how many satellites is too many, like when it comes to astronomy. We want to find ways of moving forward and mitigating without hampering the really important mission to provide broadband or to make Earth measurements. But at the same time, is there a tipping point where we have too many satellites and you just can't get the science done anymore? And there's research that still needs to be done to answer that question. We know 1 billion is probably too many, but it looks like 40, 50,000, maybe we could still do science, especially if we employed some of these mitigations. So that's something that is still puzzling us. Another thing is how to handle radio quiet zones. There's a couple special places on Earth. So down in Chile in the Atacama Desert, it's very dry. At the South Pole, it's a beautiful place to do some of the science, understanding the earliest moments of the universe. So how could we think as a society of how to protect those very specific geographic locations, maybe extra protections there, and then maybe loosen them in other places so that we really can continue to do the science? Another kind of puzzle ahead is with all of the exploration to the moon, which is very exciting. The International Telecommunication Union did establish a shielded zone of the moon where certain radio transmissions are prohibited. So it's like a quiet zone on the backside of the moon where the moon is essentially blocking transmissions from orbit around Earth and any other transmissions that are made. So that's, I think, a puzzle to think about. You have to be able to communicate to those telescopes or people operating them on the backside. So you have to have wireless transmissions, but how do we engage in that? So as you can see, there's a lot of challenging problems. We've been very fortunate to have great colleagues in industry, also working very closely with the FCC, NASA, and other commercial providers. So I think it's something that we just have to continue to work together on. And this is where, we're in this fantastic place, downtown DC. I would say, President Kennedy's words are inspiring. We do something, we don't avoid it because it's hard. We go after it because it's hard. And so I think, these mitigations are not going to be easy. They're going to be complicated. But I think, if we continue to work together, we'll be able to not close the doors to that exploration that I talked about in the beginning.
Thank you so much. If you ever wondered if there's going to be something to work on ahead, you shouldn't now, because there's plenty of puzzles still ahead. And I'm really pleased that Astroscale's with us, because my sense is that particularly the mainstream media and even the space media loves to admire these space sustainability problems and wring their hands. And one of the lines that I like to use is that we are at the beginning of the space future we envisioned. So we need to pull ourselves together a little bit, and cooler heads need to prevail, and not just wring our hands about this. We're the cooler heads, by the way. We're the ones who are supposed to kind of gather ourselves and think, oh, that's an interesting problem. Let me understand it fully. What do I need to do about it? What's the next step? What's the mitigation? How do we coexist? How do we get these goals that we have to make sense and to do it responsibly? And I think Astroscale's right in the intersection of those what are we going to do about it kind of questions. And so I'm glad to have you here, Jennifer.
Thank you, Patricia. So I have a little bit different perspective than the rest of the panel here, because they're kind of on the government side. We're on commercial services, on-orbit servicing, as the general explained earlier, and he was pretty spot on for what we do. I, in particular, am a little more in-depth in active debris removal conversation, because that's my specialty within the company. And when we talk about sustainability in space, there's so many components that go into it that all have to work together. There's this long-term picture of how do we build this sustainable space for future use. And in fact, Astroscale's vision is safe and sustainable development of space for future generations. So it's really pretty key to what we're doing. And while a lot of the on-orbit services we're producing right now are great for maintaining going forward and using them for modern satellites, things that are launching now that we can prepare for, there's also the other conversation about what are we doing about the space junk that we've inherited, right? We all know that the numbers are pretty staggering. I had some written down here. I'm not going to bore you with them. I think you guys all know what they are. But some of the things that Astroscale is currently doing that feed into this sustainability picture is LexEP is our life extension vehicle. It's launching in 2025. It'll perform fleet management and life extension services in GEO. We also have APSR, which is refueling fuel delivery systems for prepared satellites, which we should be ready to launch by 2026. And then ELSA had a demonstration mission that launched in 2021, and it's set to launch for a mission to capture and deorbit multiple objects next year. So, and these are all, great solutions for satellites that are going up now, things that are currently functioning in use, but they don't acknowledge the problem of older debris that's still up there. And when we think about the long-term sustainability of that space, just like we would on Earth, we wouldn't leave the litter on the ground here. We need to do something about it. And active debris removal is kind of the biggest gap of how we're going to get there to sustainability in this whole big picture. So that's where I come in. And then I want to show a quick animation. This is Address J's rendezvous and proximity operations animation. So this is how we would go and do the inspection and get a closer look. I'm assuming that's what's up there because I can't see it.
Yeah, it's right up. Okay. It's moving along beautifully.
Okay. So this launched just earlier this year, and it's really important that we can get close to these objects, especially bigger ones, so we can see what kind of condition they're in, what position they're in, if they're degrading, that sort of thing, so we can understand how to interact with them and dispose of them properly. And then can we switch over to the image? So this was captured. I'm going to read from this because I want to get it right because it's impressive. Address J is the world's first attempt to safely approach, characterize, and survey the state of an existing piece of large debris through RPO, which is Rendezvous and Proximity Operations. And in April, Astroscale Japan unveiled the first publicly released image of space debris captured through RPO, which is what you're looking at there. So it's important that we understand what shape, like I said, these objects are in and what condition they're in so that we can determine what the next step is to clean up. And these developments are pretty crucial to better understanding the debris and providing critical information for the follow-on steps. So, and then if we step back and think about how do we bridge that gap between the debris problem and the sustainable vision of an ecosystem in space, that is the future, we have to think about how do we get there? What's going to close that gap? And the answer really is recycling. And while recycling may seem like it's pretty far off, I don't believe that environmental reentry disposal is the right solution because that costs money and investment to understand and move forward. Now, I will say that it is currently something that's being used as a solution, and I think that it's important that we learn what's going on with that, the environmental impacts, those sorts of things, because there are certain things, objects that are going to deorbit by accident. There's uncontrolled reentry. So I'm sure you're all familiar with the battery from the NASA that fell into the house in Florida just not too long ago. And then just within the last week or two, there was some, what they believe was Chinese rocket debris that fell over a southwest village in China. So those reentries are happening, whether we're involved and engaged in that process or not. So it's good to look at and fully understand what that means. So for example, breakup simulations, understanding how something's going to break up when it comes through the atmosphere, those kind of simulations and models aren't really well developed and understood at this point. So they are highly just predictions, and so developing those tools is pretty important.
We probably need to start wrapping up. We're coming to the end of our session. I want to make sure there's time for a little bit of a Q&A here. I don't know, do you folks have questions? I see a question here. I have questions too, if you're not ready. I see two questions. Start here, if we can. Thank you. Thanks, sorry, Jennifer. I didn't mean to sorry to cut you off, but I want to make sure we got a chance. With all the thought-provoking material, we gave a chance for questions.
Thank you. Thanks to everybody on this panel. It was a great panel. My question in particular is for Dr. Colvin. So again, my name is Quinn. I'm from Astroscale US, but you brought up lasers, and I'm very interested in that. So back before I ever joined the company, I was doing a lot of research on it and came across Project Orion back in the 1990s, focused on ground-based laser stations for orbital debris removals. So I talked to Claude Phipps, who was one of the people that was on that project, and one of the inhibitors that, what didn't make sense to me at the time is why. It seemed like it was deemed feasible back in 1995, which is before I was born, mind you, and still nothing had been done. And his position was that largely there's a lot of geopolitical inhibitors, such as dual use capability and things like that. So my question is twofold. Obviously, with the ground-based laser station, you could probably address at scale and probably at cost. But the twofold question is, A, is cheaper better? And B, what's changed over the last 30 years that, reduced this inhibitor? We've seen some recent reports come out from NASA that this is still a position. What assurances do we have that this isn't going to continue to be a geopolitical inhibitor in the future?
Go ahead and answer that in like a minute or two.
Yeah, briefly.
Just try.
So I'll try. Okay. I can do this. I can do this.
you can.
So our office has been looking at both the technical and the policy feasibility associated with ground and space-based lasers for doing this. You mentioned Phipps. He came to a 2-day technical interchange meeting that I organized on this, where I got a whole bunch of technical experts together to look at the feasibility, technically, of the solution. I would say that it's not clear that it was feasible back then, technically, with what they had. And even now, the types of capabilities that you need are still a bit beyond the state of the art, most likely. However, they are not so far beyond the state of the art that they could not be developed too relatively quickly. So that's kind of the quick technical answer. Happy to talk more on that. There's been a big problem the last couple of years I've seen just like having policy conversations where the technical people don't want to work on it because they think even if they build the thing, the policy folks won't let them push the button. And the policy people, they don't want to try to make any sort of space for it because they don't think it's going to work technically, right? So there's kind of a, I don't like the chicken and the egg thing, but there's a little bit of a stalemate. So we've looked at the policy ramifications. I can't say that we've like solved them, right? But we have identified them all, and they all appear to have reasonable pathways by which this could be used responsibly. I'll just give, this is like spitball, like idea generation answer here, right? Like I'm not vouching for this. But if weaponization is one of the concerns, maybe this is not a thing that one country does alone. Maybe NASA and ESA or someone else, maybe a couple people have to push the button kind of all at the same time before the system gets used, and you have high levels of transparency, et cetera. We can talk about all the other policy issues, there's a lot, but they appear to be mitigatable and addressable. So, thanks. Yeah.
There was a question over here. Yeah, go ahead.
Thank you so much for, thank you. Thank you for your time and for your diverse perspectives on this topic. My name is Juan Carlos. I'm from Microsoft. My question is, how are you thinking about artificial intelligence, like traditional AI and more recently like Gen AI, contributing to this space sustainability challenges that you just talked about? Thanks.
Who wants to take that one?
I can try a little bit.
You got a piece of it?
Yeah. That's a fantastic question. There's definitely artificial intelligence is one of the main areas that NSF is investing a lot of funds for applications across the board. One thing that I would say is that astronomers have generally dealt with big data kind of a lot more than other folks have traditionally. And so I think there's lots of AI tools being used, for example, to determine what the object is, right? So when you take an image, it's not necessarily that straightforward. Is it an asteroid? Is it a piece of its satellite? There's all kinds of information that has to get fed in. You know, if you see variations in the light, it might be a piece of debris that's moving around versus if it's an asteroid, it may not change quite so much or so drastically. So I think there's a lot of things, you know, where AI can be used for that data analysis. And so this is also really important. So one of the big things for space sustainability is conjunction analysis, you know, to make sure spacecraft don't hit each other, but there's big kind of errors currently in the telemetry. So people are trying to push that to better and better information to kind of be able to propagate. We care about it from the astronomy perspective because if you actually know where the satellites are, you can use that as a scheduling tool. It's conjunction of a pointing with a satellite, so you can try to avoid that, but it's, you know, the same problem. So yeah, I think folks are definitely digging in, and I think that's where it's also really important to do collaborations, you know, between not just one community, but bringing in the computer scientists and, you know, the knowledge from industry.
I was going to say the same thing. The space data sort of interface to try and understand where objects are and predict and alert for collision and collision avoidance. I think a lot of the private sector companies that are looking in that space are using, you know, AI and machine learning to try and enhance that. I know we're running short. We've got time for one last question before Bradley's head falls off. Anyone else? I have a question just to let the panel finish up. you know, this isn't one that I told you I was going to ask because it just occurred to me. Each one of you is dealing with a problem that you didn't think you were dealing with probably 5 years ago. No, there's a lot of newness, a lot of evolution in the kinds of problems that come across your desk and that you're asked to deal with. What skills do you look for, or in yourself or in your team, in your agencies, your colleagues, to try and help you address that new problem? And particularly as you talk to people who are, you know, finishing their education and going into jobs in government, in private sector, in science, what do you value? What has helped you with the, uh-oh, I don't understand that problem moment? Tom.
Okay. I mean, at the highest level, the specific skill is people who aren't afraid to disagree and to not just say, that's never going to work, but to try to like actually think through problems. A lot of times people who aren't experts already in a field will just kind of defer to people like maybe me who seem like we know more, but I have myriad blind spots, right? I don't know all the things I don't know, and I need to surround myself with people from very different backgrounds who can like check me. They're like, why do you think that thing that you just said was obvious? And I was like, oh shit, actually, you're right. Like, and so some of my most fruitful interactions thus far have been with economists. So I absolutely love the opportunity to work closely with an economist, not necessarily even just like a person who knows some economics in space, but a person who doesn't care at all about space, right? Like they just know economics and how that works, and they can check a lot of things that I just think are true, and it turns out I'm way off, right? So, and I would even broaden that I think in the space community, we need more folk, like, you always need the technical folks. There's always going to be technical folks to do the technical stuff. But I think we also need to have a better appreciation of certain aspects of the humanities and social sciences. Specifically, for me, I would say economics, ethics and philosophy, history, and then also probably some medical science as well. We often tend to think of our humans in space, like we know that they're vitally important, right? It's the most important thing that we could do to keep them safe. But then when we go to design systems, they're kind of, you know, they're squishy payloads, right? And we sort of don't fully attend to their humanness and their human needs. And I think if we have more people in the space community or working with the space community that can address those very disparate skills, that's what's most valuable.
Squishy payloads, I like that. Merissa, anything you'd offer?
I'll try to keep it short, and I think this is probably coming from my experience as a lawyer and my training as a lawyer. In law school, we're trained to look at precedent and what's already been done, and we focus very heavily on like, what's the precedent on these issues? And I think one of the interesting things that's been, as a space-related regulator, has been for me personally, to kind of shift my thinking to like, maybe this isn't something that's already been resolved, and just recognizing that it really is a new issue and it requires some new thinking and some new ideas about how to go about things, because I think it's a little bit antithetical in some ways to the way that we get trained up as attorneys. So I think that's maybe a little bit to my experience, but has been an interesting thing I've seen.
Know the precedent,
But be able to move beyond that.
all right. Ashley, how about you? You're a scientist. You have new problems all the time.
I would say so. In grad school at one point, I was like, why should I finish this? There's like 3 people in the world that care about this topic. And someone told me that doing a master's or a PhD, or even working on a project in a company that you're working for where you really dig in, shows your ability to learn something very deeply. And I think that's very important. That, along with kind of a continual curiosity. I will say that the Nobel Prize winners that I've met, one is Saul Perlman, who got a Nobel Prize for expansion of the universe, looking at supernovae. Probably one of the most curious people I've ever met, just asking questions and wanting to understand, and not assuming that their base of knowledge was correct. And I think that's where, with a new problem, you can really dig deep and just continue to be curious to kind of really try to understand and find solutions.
Thank you. Jennifer?
So for me, I think for long-term complex problems, the ability to continually look back at the problem statement and reassess it to your current conditions, because they are, in a long-term problem, your conditions are constantly changing. So not losing sight of what are you trying to do and why in reference to where you're at in that moment is really important.
So we're not ready to turn over space sustainability to y'all yet, but it's coming. Thank you all. Thank you to the panel for thinking big and for sharing what you're doing about it. Thank you.
Wonderful. Well, thank you, Patricia. Thank you so much to the panel. It's great to have the cherry on top. Is that, I think, what we were referring to that panel as? So that was wonderful.